All right, so let's take a look at this and let's see how the Pythagorean theorem connects to the distance formula. Let's just say you have these 2 points, right? This point is 1 comma 1. I'm going to put it right here, 1 comma 1, and this point will be 3 comma 5, okay? 3 comma 5. And I'm asking you to find the distance between this point and this point. Like, how long is it, right? And notice it's a diagonal, so there's no way that you can really measure it, and because we want the exact distance. And we don't count by grids going up or sideways. So what's going on here? Well, it's interesting because because you have any diagonal line, whenever you have it, you can always like drop lines that extend outward like this. And what we end up creating is actually a right triangle. And with any right triangle, basically this, because this line is across on the 90-degree angle, this is going to be your C value. So basically, you're using the Pythagorean theorem ultimately to solve for the distance, right? And so let's take a look at this. Well, the way that I think about the distance formula using the Pythagorean theorem is this, right? It's how do you go from 1 to 4? I mean, what's the change in y? Like, what's this leg right here, right? To go from 1 to 5, it's plus 4. Right? How do you go from here to here? Well, to go from here to here, it's actually plus 2, right? And so, right, it's the same thing that we do slope, but you want to think about it as like this, like it's like the same thing as a squared plus b squared equals c squared. We're trying to solve for c squared, so we're going to leave it blank. But we know that the change in this leg is 4, right? So it's 4 squared plus, and the change in this is 2 squared equals c squared, right? And so let's solve for this. Like 4 squared is 16, plus 2 squared is 4 is equal to c squared. At this point, 16 plus 4 is going to be 20. And so in order to get to the final answer, we simply take the square root of both sides, right? So c is equal to the square root of 20. But this is not the final answer. Why is this not the final answer? Well, it's because 20 is not simplified, right? It can be simplified even further. So we go back to our initial method of simplifying. We divide this by the highest perfect square, and in this case the highest perfect square would be 4, right? So root 4 root 5, and then because from here you just do c is equal to 2 radical 5, and that would be the distance from 1 comma 1 and 3 comma 5. Now this is the intuitive way of doing the distance formula. You could also think about the distance formula as the equation, right? So the equation is d equals square root of parentheses x2 minus x1 squared plus y2 minus y1, right? Squared. And you could go through all this trouble. So let's actually show you very quickly. D is equal to the square root of, let's just say this is 3 minus 1 squared plus 5 minus 1 squared. D is equal to the square root of 2 squared plus 4 squared. D is equal to 4 plus 16. D is equal to square root of 20. D is equal to root 4 root 5. D is equal to 2 root 5. Okay. So ultimately, with the distance formula, you get the same answer, but understand that conceptually the distance formula is coming from the Pythagorean theorem. Okay.